Okay, so now we're going to look at that same reaction, the decomposition of dinitrogen pentoxide, and we want to know how long it takes for 95% of that reactant to decompose. All right, so our plan, if we start with our plan, let's just write mathematically what the question is, basically. So we're looking for how long does it take for the concentration of N2O5 to be equal to 5% of the initial concentration. Okay, so 95% of it has decomposed. So how long does it take for 95% of that to decompose, or for 5% of that initial concentration to be left over? And so we can use that same relationship for, again, this is still a first order reaction in terms of the reactant. And so we can take the natural log of the concentration of N2O5 at the given time, which the time is what we're looking for, divided by the initial concentration, N2O5 initially, and that's going to be equal to negative KT. All right, and so what we're looking for is when this numerator is equal to, so I'm going to write this below. So when this numerator is equal to 0.05 times the concentration of N2O5 initially, divided by the concentration of N2O5 initially, those two things cancel. So now I'm just taking the natural log of 0.05, and that's equal to negative K T. Right, so if I solve this, taking the natural log of 0.05, and that's equal to negative, remember in the last video, I converted this into minutes, and it was 0.416 inverse minutes. All right, so we have 0.416 inverse minutes, and I'm solving for t. Okay, so if I just take the natural log of 0.05, divide by negative 0.416 inverse minutes, what I end up with is 7.2 minutes. So it takes 7.2 minutes for 95% of that initial reactant to completely decompose.